Okay, this is homework 3, part C. A pipe of length L and diameter D has fluid of viscosity mu and density rho flowing through at an average velocity of V arising from a pressure drop of delta P. Write the dimensional matrix for this problem and explain how solving for the null space of this matrix yields dimensionless groups that describe this natural phenomena independent of the choice of units for mass, length, and time. Show how the Reynolds number arises from this analysis. So I've already done the outline of the matrix, and the numbers for this matrix come from the equation PA equals kg over meters times second squared. So from this, we can tell that, so we have kg on top, so that'll be 1 meters on the bottom, that'll be -1, and second squared on the bottom, so that'd be -2. L, that's related to meters only. That'd be 0, 1, 0. D, same thing pretty much. Viscosity, that's gonna be 1, A1, A1. Rho is gonna be 1, -3, 0. And V, that's gonna be equal to 0, 1, -1. Okay, so we know that this matrix has 6 columns, so that'll be, we're gonna have x1, x2, x3, x4, and x6. Okay, so the numbers in this are related to the equation RE equals rho V D over mu. So from this, we can tell there's no P and no L. So x1 and x2 are going to be equal to 0. So 0, 0. Then we have D. So D is equal to 1, and that's on the top. Mu is on the bottom, so that'd be negative. Rho is on top, so that'd be equal to 1. And then V, that is equal to 1. So now we can start reducing this matrix because we basically want an identity matrix on the left side, so we need to reduce it so that we get that. So I'm gonna rewrite the things down here. So this top row can stay the same, so we get 1, 0, 0, 1. Alright, so first, for the second row, I'm just gonna add the first row to it to get a 0 here. So 0, 1, 1. So we 0, -2, 1. On the second row, I'm going to add 2 to get a 0 here. So 0. So what we're going to have to do next is we're going to have to swap D and V, because that will help us to get an identity matrix here, because with how it's set up now, we can't get one with D being here. So we're just going to swap them. Oh, accidentally. wrote it the same. So now we have V here and D here. So I'm running out of room, so I'm just gonna erase this one and have it be our step 4 now. Erase these. So this top row will be the same. So for this one, I'm just gonna add. We're just trying to get rid of this one first. So I'm just gonna add row 3 to here. So we get 0, 1, 0, 1, 0, 1. And then I'm gonna multiply this bottom row by a -1 so that we get a +1 here. 0, 0, 1. This will be -1, -2, 0. Start doing the x1 through x6 stuff and testing out different numbers to see what we get and doing that. So again, we have x1 through x6. Six. Okay, so we have x1. So the first one we're gonna try is when x4 is equal to 1 and x5 and 6 are equal to 0. So when we plug in x4, this equation, so that would mean x1 is equal to -1. This one will also be equal to -1, and x3 would be equal to 1. So then we get, so if x3 is 1, so we get v. So this will be our first pi, so I'm going to erase the original one over here. That gives us more room. So pi 1 is equal to, so v and mu are positive, so we get v mu over, and the x1, x2 are negative, so p l. So that's our first pi number. Okay, so now we're gonna do the same thing. So now we're gonna do the same thing, except we're gonna do x4 is equal to 0, x5 is equal to 1, and x6 is equal to 0. So x5, so that means x1 is still -1. This one will be equal to 0. X3 will be equal to 2. So, I mean, we get X3, so V, so we get V, and since 2, we get squared, so V squared. X5 is P. Oh, wait, no. These look weird, I think. This one's P and this one's rho. So then we get X5 rho over P. I think that's it. Pi 3. Move this a little different. So now we do X4 is equal to 0, X5 is equal to 0, and X6 is equal to 1. So we can plug X equals 6 and X equals 1 in, so this will, X1 will be 0, X2 will be -1, and X3 will be 0. So X6, D over L. Step is to do pi 2 over pi 1. So let me get V mu Oh wait, no, I wrote backwards. So V2 over, or pi 2 over pi 1. So V2 rho over P, and all that over V mu P. So we can cross out this. This one will be going. So we just cross multiply basically. So we got, okay, so we do that. We get rho V L over mu. And then to get Reynolds number, we just multiply it by pi 3, so it'll be times D over L. Get rid of the L's. So we do all that, then we get rho V D over mu. And that is Reynolds number.